Okay, so this is the intro to the video. I had like a fully filmed intro explaining what happened. I lost that, so you just get a horrible voiceover with maybe some subtitles. But basically, I was given the project of a Stirling engine and had 2 weeks to do it, which, with how I was doing it with classes, was about a week. So over the first week, I was working on a design that wasn't going to work, so I decided to restart, and that's where we are now. Anyway, enjoy the video, and I'll go ahead and fill you in on parts that I feel like I need to fill you in. So you have the hot piston and the cold piston. Basically what the hot piston does is air gets hot, so it expands, so it goes through all this and makes this piston move up. So the piston moves, wheel turns the other piston, and the air is now in the cold. Well, because the air is in the cold, it contracts, which causes that piston to go back, and all the other pistons go back, wheel spins again. That's perfectly fine. The only problem is, it's like a piston. So you can't have air leaking out, because if you have air leaking out, then it's no longer a closed system. A Stirling engine needs to be a closed system in order to work, so the pistons have to be perfect. The other problem is it's a very weak engine. So if you just have freaking super tight seals, but you can't get air moving because the seal's too tight, suddenly all that force is going to go nowhere, and your piston is going to be absolutely worthless. So the problem with engineering is we don't have a 3D printer. We don't have anything. We just have a 3D printer, so I have to custom build my parts, as I will show. Other than that, that is the main problem with the Stirling engine, and I will get to more to it after I actually get the Stirling engine done. Okay, so I'm sure that editing me decided to, well, told you what happened, but basically, I didn't go to the store to get syringes because, well, I figured out, A, plastic ones would have sucked for what I needed them for, and B, glass ones are way too fucking expensive. However, I do have a grandpa that is pretty good with machines, so we made some custom pistons. A and B, we got the plugs for them right here, and then we also have the, what's it called? The regenerator. We have the regenerator right here, so really all we need to do is put them together, get the flywheel, and then we'll be done. Once I get the flywheel done, it's probably going to be, because this is Sunday, this is the day after, so I'm probably going to take these to school, and then you're not going to see them again until after school, well, till after the project, because once the project's over, then I'll get all my stuff back and I'll be able to show it to you. Who knows, I might take this home and work on it, but Okay, so this is the final design of the Stirling engine. I used a fidget spinner for the flywheel because we just had like a ton of those laying around. And you could see the pistons I made. I have 3D printed brackets which just slide on. The generator, I have it all set to a block of wood. And when I turn it, it does actually work. But, like, this flywheel's only meant to carry momentum, and I just have to, like, put something on top of here to keep these from flying off. But that shouldn't take too long. I can probably do that in break. But I'm not too confident in this design getting anything above a C. Hell, even a C's wishing, because, like, yes, it's original compared to everyone else. Everyone else went with a YouTube video of like 2 pop cans. I'll see if I can find it and put it here. but I'm one of the few that actually designed it. So I gotta hope that, well, originality is one of the points, because if I do, I'm gonna get a 10. Either way, yeah, this is the last thing, and I'll go ahead and update you on what grade I get. So, yeah. Okay, so I got my Sterling engine back from my instructor, and he gave me a few, like, he told me to take it home over the weekend because he's given everyone an extra day to work on it. So anyway, there are a few problems with this design. There's just a lot of friction in, like, the pistons and all that, because, like, if I can't get it spinning too fast. And I'm not sure where that friction comes from. I'm pretty sure it's one of the pistons. So I'm gonna have to change that. Which is hard because then I need to shape them down and add some sort of seal here. But once I did that, it should be all good to go. This part. So for those of you who don't know, this is going to be, I'm gonna draw it, but piston A, piston B, and the regenerator, about this angle, 45 degrees, all need to have the same amount of air. They need the same volume of air in them. Now, obviously that's whatever it goes here. This piston is now fully down, has no air in it. The regenerator is pulling the air here. Bada bing, bada boom. The Sterling engine works. The flywheel causes momentum. I never did the calculations for that. I didn't do calculations for any of this. So I have to calculate how long I can have the regenerator, calculate how big this needs to be, probably remove the internals of the piston, and fix it with like a balloon or something, I don't know. But still, we need to get that working. Because with the friction being this big, like, the amount of, so friction, static friction and kinetic friction. Static friction scales with the force, and then kinetic friction doesn't scale. You need more you need more force to overcome static friction, so once I get it moving, there's less friction. But in order to get it moving in the first place, there has to be a force against the static friction. So static friction scales with the force, and only turns into kinetic friction when you overcome it. The problem is, the force needed for the static friction is a lot. Because, like, I can't just tap it and it go. So the force for the static friction is a lot, which means we need a lot of pressure on the inside, and considering that this isn't completely airtight, it's not airtight enough. It can move. It can very much move. It can push the pistons with pressure, but the only problem with that is you need a lot of it, and that means we need a bigger temperature differential, so we could either A, make this one super cold and this side super hot to get basic motion, B, get the friction down somehow, or C, restart. Which I don't really want to restart. So I'm going to do some more calculations. And I'll go ahead and have, like, a freaking thing. Video or something. Explaining what calculations I did. So I'll be back. Okay, so it turns out I'm a failure of an engineer. The Sterling engine I was working on has too much friction, and yeah, just too much friction, too long of a regenerator, and it's just generally a bad design. So of course I'm just following the rest of the people. I'm becoming a sheep and using a can with freaking steel wool and a balloon piston.
So, yeah, I spent like, what, 4 hours yesterday? 4 hours, right, cameraman John? He's making the face right now. Anyway, yeah, I spent like 4 hours. Wait, can I even say that? Would William Osmond actually care? I don't know. Anyway, I spent like 4 hours on that thing, trying to get it to work. It ended up not working. Then I burnt my hand a few times. So, safe to say, I am a horrible engineer, and everyone should look down upon me for doing that. Anyway, end of the video. No cameraman. I still have the outro to do. If you want to watch more videos like this, just wait a minute, because obviously they just take a lot longer than the let's throw Linux on freaking iMac videos. But yeah. And maybe next video I won't have a deadline of a week. Maybe then. Maybe I won't have a deadline of a week and can actually get it functioning. Anyway, see ya.